Welcome to another episode of Mastering Cybersecurity, developed by baremetalcyber.com. Let's dive in. Application Programming Interface, API, describes a contract that lets software systems exchange requests and responses across well-defined paths. A helpful image is a set of digital pipes carrying small packets of instructions and data between services that rarely sit in the same room. Those pipes are attractive targets because they often reach directly into core business functions, sensitive records, and powerful back-end capabilities. When an API is misconfigured or poorly defended, an attacker can skip the front door and talk straight to the systems that actually do the work. Clear structure, predictable messages, and reusable components make APIs efficient, yet they also concentrate risk in a few exposed places. Seeing the API as both a convenience channel and a security boundary sets the tone for disciplined design and vigilant protection. Most API traffic rides on Hypertext Transfer Protocol, HTTP, which organizes communication using endpoints, methods, headers, parameters, and status codes. An endpoint is a specific address that maps to a capability, so the path itself becomes a boundary that must be deliberately published and controlled. Methods such as get, post, put, and delete express intent, which means enforcement can honor the verb and refuse actions that do not match policy. Headers and parameters carry identity, tokens, pagination hints, and filtering instructions, so they require validation and careful logging. Status codes disclose success or failure in compact form, which affects how much information an attacker can learn through trial and error. Every HTTP element is a lever for both functionality and defense when defined and checked with precision. Identity and authentication start with proving who or what is calling, then maintaining that proof through the request's lifetime. Basic methods include static API keys and basic authentication, which are simple to implement yet require strict storage, rotation, and scoping to prevent misuse. Token frameworks such as OAuth 2.0, OAuth 20, delegate login to a trusted identity provider and issue short-lived credentials that can be revoked independently. A compact JSON Web Token, JWT, can carry claims about the caller and expiry times, which reduces database lookups while demanding careful signature verification and clock handling. Safe key stewardship means keeping secrets in dedicated services, not in code or shared documents, and rolling them on a predictable schedule to limit blast radius. A small example is rotating a read-only service token monthly while monitoring for any request that still attempts to use the retired value. Input validation and parsing are frontline defenses that convert messy edges into predictable shapes before business logic runs. Strict schemas define which fields exist, their types, ranges, and formats, which blocks surprises and simplifies code that follows. Allow lists beat den lists because they declare the only acceptable patterns, leaving everything else outside the gate without debate. Defensive parsing prevents injection into structured query language, SQL, command shells, or template engines by enforcing types, encoding output, and rejecting unexpected characters. Controls that stop mass assignment ensure the server, not the client, decides which fields are writable and which are computed internally. Parameter tampering is blunted when servers recompute sensitive values, ignore unrecognized fields, and log rejected input with just enough context for safe analysis. Transport protections keep messages confidential and unmodified across networks that are always assumed hostile. Transport layer security, TLS, must be used for every connection, with certificate validation enforced to prevent on-path interception and silent downgrade attempts. Mutual TLS adds client certificates so both sides authenticate at the connection layer, which is especially valuable for service-to-service calls inside private networks. Cipher and protocol choices should follow modern baselines, which reduces exposure to known weaknesses without chasing unnecessary novelty. Cross-origin resource sharing, CORS, is a browser permission system that governs scripts, not a security boundary for direct API calls from servers or tools. Thinking of TLS as the sealed pipe and application-level checks as the valve keeps responsibilities clear and non-overlapping. Abuse often looks like legitimate requests repeated or varied in ways that strain capacity or mine data at scale. Rate limits cap requests per identity or address over time, while throttling slows bursts to keep systems stable and fair for everyone. Quotas set upper bounds for daily or monthly usage with clear error responses that communicate the current consumption and reset windows. Pagination reduces response size and discourages scraping entire datasets in a single sweep, which keeps memory predictable and monitoring signals cleaner. Independency keys prevent duplicate processing when callers retry during network trouble, which protects inventories, payments, and audits from double spending effects. Timeouts and sensible retries form a circuit that balances reliability with cost while keeping error storms from cascading across dependent services. Secrets and keys must be treated as toxic data, whose handling is auditable, reversible, and minimized at every stage. Dedicated vault services store credentials encrypted at rest and control access with short leases, which remove secrets from codebases and developer machines. Environments are separated, so development and test cannot reach production resources, with distinct keys, policies, and monitoring streams that expose cross-contamination quickly. Regular rotation narrows the window for misuse and proves that revocation processes work under real conditions instead of only on paper. Request signing with a hash-based message authentication code, HMAC, binds message content to a shared secret, which allows recipients to verify integrity even when intermediaries are untrusted. Logs and error messages must never echo secrets because harmless-looking diagnostics often become permanent leaks in unexpected places. Error handling and response shaping determine how much an outsider can learn from every misstep. Verbose messages that include stack traces, table names, or configuration values teach an attacker exactly where to push next while helping little during normal operations. Consistent status codes paired with minimal, user-friendly messages keep behavior predictable without disclosing internals that belong only in private logs. Data minimization sends only the fields required for the client's next task, which reduces exposure and simplifies privacy obligations. Output encoding ensures values return safely across contexts like JSON, HTML, or logs, which prevents injection from completing its last hop. A disciplined pattern distinguishes between what humans need to fix a problem and what a stranger should never see, and it enforces that split relentlessly. An API gateway acts like a control tower that sits in front of services, enforcing authentication, authorization, rate limits, schema validation, and logging from a central point. Centralization provides consistent policy and a single place to instrument visibility, while also creating dependencies that must be scaled and tested with care. A service mesh weaves security, routing, and telemetry into the network layer, often through lightweight sidecars that standardize encryption and identity between services. Mesh features such as mutual TLS by default and uniform retries remove boilerplate from application code, which elevates overall discipline when teams vary in experience. Both patterns introduce operational trade-offs, including added latency, configuration drift risk, and the need for strong change management. Choosing between gateway, mesh, or a hybrid depends on system size, team skills, and the kinds of threats most often observed. Detection closes the loop by turning traffic into signals that reveal misuse quickly and accurately. Structured request logs capture timestamps, identities, endpoints, methods, parameter shapes, and outcome codes in consistent fields, which makes analysis and correlation straightforward. Trace identifiers follow a request across services, so slowdowns, errors, or suspicious bursts can be tied to a single narrative without guessing. Anomaly rules watch for impossible rates, forbidden method combinations, or sensitive endpoints accessed in strange patterns, which often surface scraping and credential stuffing. Privacy is preserved by redacting tokens, secrets, and personally identifiable information, PII, while still keeping enough context for investigations and learning. Clear alert thresholds and on-call runbooks turn raw observations into measured responses rather than noisy pages that burn attention without improving safety. Security that lasts is built into the lifecycle instead of added during emergencies, which means the contract itself deserves first-class treatment. Contract-first design defines messages and error models before code, which allows teams to write tests, simulators, and documentation that agree with production. Documentation explains fields, constraints, and examples in plain language, which reduces accidental misuse as teams change and features expand. Versioning and deprecation policies let services evolve without breaking collars, while keeping retired endpoints behind clear deadlines that are visible and enforced. Pre-deployment testing includes static checks for insecure patterns, fuzzing that mutates inputs to find parser bugs, and dynamic analysis that exercises running systems like a curious stranger. Continuous integration and continuous delivery, CI and CD pipelines, automate these checks so every change meets the same standard without tiring repetition. Strong API security looks like a layered model in which identity, authorization, validation, transport, abuse prevention, secrets handling, error hygiene, centralized guardrails, detection, and lifecycle discipline reinforce one another. Each layer answers a different question about who is calling, what they can do, what they sent, and how the system behaves under pressure. The result is not a single silver control, but a coordinated set of boundaries that reduce surprise and keep failures contained. Trade-offs are acknowledged openly, and evidence is gathered continuously through logs, traces, and tests that show the controls remain healthy. Many organizations find meaningful early gains in well-defined schemas, prudent rate limits, and measured logging that clarifies what truly happens at the edges. The key idea is reliability through clarity, where every path is intentional, every message is shaped, and every decision can be explained. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.